Hey guys, thanks for watching. As promised, I'm releasing the code, and I'm not a developer, so if you have any comments that can make it more efficient, let me know. But as I said, I'm not really not a developer. That's not my profession, so I really just coded in um, just to really enable my smart home capabilities. The code is written in Node.js, and I'm using Lambda service that's also in Node.js. And if you do not know coding and you just have an Echo and you want to enable it for these devices, then I really don't recommend you moving further because it's going to get pretty technical. It's going to get into the actual code. If you do want to understand what's going on, then this video might be a good video to you. It'll give you a general idea of how to incorporate everything and just how everything kind of comes together. So in order to understand exactly what's happening when you talk to your Amazon Echo, you first have to understand the process. Now, this example is not going to be the example that's happening in my environment, but it's just to give you a general idea. So I'm gonna mark and change things around, but I just grabbed this diagram from the internet. So when you say Alexa, turn on the kitchen light, it's going to make a API call to the Alexa service, and Alexa service is going to be the kind of the brains behind taking what you say naturally and converting it to either functions or variables that can be used in a program that can extract those words. So the job of this Amazon service is to take what you say naturally and convert it over uh, into actual words, into actual, and just converting everything. When it gets passed over to the Lambda service, Lambda's job is to take what you say and pass it over to a function that particular function is going to do a certain job. From the Lambda service, it's going to pass it to device cloud. So if you have like a Nest or a smart home device that's already integrated with the cloud, this is good because it follows that path. It talks with the vendor, and then the vendor will talk to your devices that you already have interconnected. Probably already talking to the internet, connected to the internet like a Nest Cam. So it's going to go and talk to your kitchen light. This is not what's happening when we do it. When we do it, it's going to be a little different. It's going to be not turn on the kitchen light. It'll be, we're using it to do Plex. We're using it to do control the TV, and we're using it to control Tivo. In order to control that, the way I'm doing it is it's not going to talk to the Smart Home Skills API. I haven't used that feature yet. It's a new feature, so I might look into that later. But we just have a custom custom skill that we made. Okay, and then from that custom skill, it's going to go over and talk to Lambda. From Lambda, it's not talking to a cloud, but it's actually going to talk to your device directly. Okay? How does it do that is it talks to my server here. I have a home server. And the server is programmed in Node.js, and it has an API interface exposed out to the internet. Actually, really exposed only to Lambda's IP range. And it will talk to your TV. And it will talk to Plex. And it will talk to my Tivo. Now, each component is different. I had to just build different drivers and different functions to talk to each component, and so you really just have to program everything. It's not plug and play. It wasn't really made yet, but I think in the future it will be. So that that is basically how we are doing it. So let's talk about the Alexa service. So, like I said, in Alexa, you have to go to the developer toolkit, and then we're going to go to the interaction model, and under the intent schema, this schema is what's used to map your natural language to functions, and it's in JSON. The natural language is right here. This is what I'm saying when I say change the input to HDMI input number. It maps the input number here at 1, 2, 3, and 4. When I say turn closed captioning on and off, it's mapping to on and off in the closed captioning. When I say turn the power on or off, it's mapped to here. And when I say turn everything on or off, it's still mapped to the power. So as you can see, it's just mapping everything to slots. So the slots that I need to map are the ones I built here. I need to know power on off. That's a variable I need to know. I need to know the number of the input number, but I don't need to know the rest. So it needs to call the function and then map the what I need from that sentence that the person is saying, the phrase. So that's basically it with the Alexa skills. You build the intent schema, you build the utterance, and then you map it to Lambda. When you map it to Lambda, you have to make sure, then this is the code in Lambda, and this is going to be the Lambda service. And I'm going to show you a different screen. So this is the Lambda service, and the Alexa skill is going to be a module here that helps you kind of map everything from the Amazon Echo and understand what's coming in. You also have to map the app ID. This makes it so that it sets up kind of security to make sure that only your Amazon Echo is able to talk to this Lambda service. So let's take, for example, power on or power off. This one, you see it's looking for, it's called the TV power intent. This is something I made, TV power intent. It's mapped to this TV power intent. It passes the variable power and TV power intent. Let's look for it. So here's a TV power intent, okay? And it's going to map the function, and here's the intent coming in. That is going to be the intent coming in, the variable of power coming in. So intent, slots, which is in the slots, the power, and then the value. The value of what's the value of power? We're going to put it in a header. And then when we put it in that header is used when it sends the command to my Bravia API. Okay? So my Bravia API is right here. So the send command. Now I'm not revealing information here. This is all in a config file that I have loaded. But it's going to be the external IP. It will be the external port. It'll be the path, and it will be the header. The path is already defined when in the send command, because on the TV power intent, that's the path. Okay. Then it does a request to my server. Okay. So now what you're seeing is from Alexa service, it's going over here. Okay. Now we already have that code with the intent calling my own server. Now it's going over here to my server. Okay, so now it's calling my server. My server has these routes built out: Plex, Sony Bravia, Tivo, Couch Potato, and Twilio. Okay, and this is just a simple statement just to verify that it's working. So in that path, we are calling Sony Bravia and power. So let's go to that. So let's go to that actual route. So here's the route for power. And here's the request headers for power. And it says user request to. So I'm logging a lot of things in my code just to see what's going on. I was trying to figure things out. So I'm logging a lot of things to make sure everything's working properly. So I set a switch statement for power. And the reason is my wife, she would not say turn the TV active or turn the TV standby. But on the Bravia, when I build a function to retrieve the status if it's on or off, it's not going to provide on or off. It's going to tell me active or standby. So I have to build a switch statement to match those words. That on is related to active and off is related to standby. This is just to make sure it correlates. So now when I call the power status, I built an error statement to, if there's an error, but if there's no error, that code response needs to match the power intent. So the power intent was active. Code response is also active, meaning both you're asking it for it to turn on and the code response back. If it's on as well, then the TV is already on or off. So it's not going to really launch a command to turn it on or off. But if it's not and it's different, then that means proceed and go ahead and turn off or on. This command, IR code request, is going to be really sending a dumb signal to power. It's just really pressing the power button. That's how Sony kind of built it. Is they have IR code requests for anything, possibly anything you could do with a remote. The good thing is you can have access to a lot of features. The bad thing is if you're familiar with APIs, it's very limited. You can't. It's not as powerful as a true API where you can do various tasks more easily. When you want to control volume with the infrared code, you're pressing the volume button multiple times. If you could just pass the API command with a volume with a number 30 or 40, then that's a lot more, that's a lot more better, right? So an IR code is just going to be very simple, but it works. So we got it working. With video input, it's the same way. So with video input, it's a little different. I could actually send a number, and then it can. But when I send a number, I'll show you what it looks like. See, I'm mapping the number to an infrared code. I can't really just pass the number. I have to map it to infrared code. That's how the Sony Bravia is, and that's how I actually got it working. So different things. It's really finicky. Put a comment if you have a Sony Bravia and you are having trouble getting it working, because with the Bravia, you also have to. You can't actually talk to it easily. It's not open access. You actually have to go through a lot of authentication hurdles to even get it working. So if you're having trouble, I could make a separate video to talk about the Bravia and help you, overcome this. Now, my Bravia may be different from your Bravia, so keep that in mind. And there are different generations, different versions. So whatever works for me may not work for you, but post a comment and give me your contact information, and we could try to figure this out. Again, there's gonna be some coding, and you're gonna have to be familiar, and you can't be scared to code this. Otherwise, you'll have to wait for Sony to release something official. So that's basically how I got the Sony Bravia up and running. When you look at the code, when you look at the Tivo, it's going to be a similar thing. it's going to be similar. When you want to request for a TV show, let's say for example, or a movie, you're going to have to play the movie and the title name. When you pass the title, you know, I put some titles here, but that doesn't encompass anything you're saying. When you pass the title name, it'll launch the search movie intent to play on Plex, but doesn't mean it's going to play it, because it doesn't. You could say play a movie, but it doesn't know what the ID number of that movie is. You know, in Plex you need an ID code or a number to identify what that movie is to play exactly. You can't just say a word and it's just going to play it. It's not as it doesn't know how to correlate that. So you have to build a way to do that. So with Tivo, it was a little different. With Tivo, we have the search movie intent, we have the title name, and then we send a command to search a movie on Plex. But on Plex, we have to find the best matching movie. So there's an algorithm in this code, and it's just, you know, it's fairly simple. I think I got it from another Plex API code, or tried to figure it out. But it's sort of basically breaks apart that title, tries to match that string with other titles, and then tries to play the best matching title. So when you say when you say movies have trilogies, you're gonna have to say more than the trilogy name. Otherwise, it's gonna just play you a random movie in the trilogy. So in search movie, we have it logging, we have the movie name, and if it's undefined, then it just had trouble, you know, finding that movie. But we launch a function to get the movie list. The reason we want to get the movie list is then we take that list, and then we will find the best movie in that movie list. So now we have the movie name. We can compare it to the list and see if that movie is available, and also see which one's the best match. So when you ask for a certain movie, it's not going to play you something else. So it's just going to find you the best matched movie based off whatever parameters was in the algorithm. And then it will play the movie. Now, in order to play the movie, it's kind of, I don't know if it's more simpler now. I'll look into it, but the way I did it was I got the rating key. And when I got the rating key, I honestly just went directly and bypassed sending it to my Plex media server and telling my media server to play it onto the player. I just went directly to my TV and then passed those parameters and played it with the key. If you don't do it this way and you do it the other way, it's just you have a lot more code. This when doing it this way directly, I was able to just pass the target client identifier, the machine ID, the key of the movie, and the address and port, and then boom, it plays. And you just talk to this port. This port is available to talk to when you install the Plex app. This player is available. Any device that can play Plex has a port open for Plex media server to talk to it. So any device, and at least that's what it is now, or what I think is set up. So that's basically with Plex. The same thing with TV show. To find the best TV show with that title, and it will find the newest episode and then play that title. So very simple. For the Tivo, how I did it was the Tivo doesn't have API. All it has is Telnet. So I needed a Telnet NPM module in Node to Telnet to the Tivo. Okay? So what I would do is, I'm reading my code. The user requests a channel change to a certain channel number, right? But you don't know the number of the channel. You know, if it's a cable company, you don't really know the channel. After a while, you start knowing the numbers, but still, you still don't probably know all the channel numbers. So what I had to do was I built a channel list. The channel list is going to be Where is it? In Tivo, in the channel list. So the channel list is just really a mapping one-on-one, saying that Fox is 300, CBS is 301. So all these names is related to a channel number. Okay. So then from here, when I go to the TiVo and I want to change channel, the channel that's being provided by Alexa maps to the channel number. And then I could build a code. TiVo is going to be like the Bravia with infrared commands. It's very simple. So the command would be, when you telnet, it would be set channel with the channel number. And when you press enter, it'll do it. It doesn't have authentication or anything, so it's going to be very open. So this is why you don't want to open your, I'll talk about it later, but you send a carriage return. You send an enter, and then you're good. And then you send you send to TiVo with the code. Okay, send to TiVo. Basically, to if you can try to understand, is we initiate a new telnet session. We log into TiVo on that port. We then we have a shell prompt, and we're looking for this message in the shell prompt. Then when the connection is established, we execute our code, and then we close the socket. We close the connection. So we log in, we send the code, we log out. We close the socket. So same thing with closed captioning. We send the infrared code CC on or CC off. That's closed captioning on and off. So this list of commands is available to the internet, and you can just look it up. It's everywhere. But yeah, same thing with power. You go to live TV and standby. So these commands with the TiVo, that's basically how you do it with TiVo. It sends telnet commands, and then you just have to build a module to telnet, and you just have to map it all the way through from Alexa, and yeah, just map it all the way through so that it would talk to your devices. What I was going to tell before is the way we're doing it was not the way I did it before. Before I did it, it was like this. It was the Echo would talk to the Alexa service, and then the Alexa service would talk to Lambda, and then Lambda would actually talk to all my devices. But in order to talk to all my devices, you don't have every single device does not have a external IP address. It maps to a router here, right? There's a router. Everybody's got a router. You gotta have a router to have internet. So there's a router, and usually it's too simple, where you can't really block outside it. You can't block. You can only open. You can NAT ports and do port forwarding, but you can't block source IPs or anything like that. So you're poking holes that anybody else could try to access those devices from internet, try to log into your devices. So every hole you poke is exposing you more and more to the internet. So what I did was, instead of doing a router, I wanted it to go to Lambda, and then from a Lambda go to my my server, and then my server is kind of the gateway, and it will talk to everything else. And on a server, you would just with Linux, you could, on IP tables, you can set rules to say only these IPs can talk to my server. So it kind of blocks everything from talking, and it kind of controls things. So that's it. That's basically how I got everything working. I don't know if you noticed, but there is a couch potato. In the future, there's going to be Sonar, and there's going to be Twilio. So there's going to be more modules being added later. But if you're familiar with couch potato, I'm going to try to make Alexa add movies to couch potato. gonna have Alexa add new shows to Sonar, and also because the code's fairly easy to integrate with other types of methods. I'm thinking of also adding text messaging as well. Meaning, what would happen is you would Twilio is a text messaging service. You would text it. It would provide numbers, and when you text the number you subscribe with, it would map to an API. So you would text it, and it would point to my server. And you could do things where you can say add a TV show, and when you text it, it'll map to my server. My server will respond back, and that response will be sent as a text message back to the texter, and it will say what TV show, and then you would reply back and say The Walking Dead, and then it would go to my server, and my server would search for The Walking Dead, determine if it is already added, and if it's not, add that show and respond back saying it has been added. So that's gonna be something pretty cool, because then you could do that with Alexa as well. So that's something I'm working on as well. So stay tuned, subscribe if you're interested. If you want, please comment if you want to see anything else, or if you have any other suggestions I could also do to, increase my smart home capabilities. So yeah, that's it. Thanks for watching, guys.